Hello friends, today I am going to discuss about how to write beautiful code. That is, in software design we all write codes, but uh, well written code is clearly distinguishable from a ugly code. So how to write beautiful code? Beautiful code means two things basically: manageable, that is in future if we want to change the code, or if you want to test the code and add new things to it, so that should be pretty easy. There should not be so tough that we can't do it. Like for example, yeah, I can cite one example here, that is Microsoft Windows 95 and 98. These versions, actually Windows was having around 50,000 faults, known bugs, but they can't correct it because the design was not done by following these principles, which I am going to discuss. So many faults were there, but the design was so coupled that if you go to correct one fault, then many other faults are generated. So Microsoft engineers can't do anything there. So 1 minute, let us see, and understandable, that is if a third party reads your code, then he or she should understand it. So what should you do? Basically this is a very detailed subject, but I have come out with 4 most important points which I feel so. They are: number 1, pick an appropriate design model, like waterfall model, that is used in basically in general software. Evolutionary model is if you want to have versions, like it's basically based on the concept of nature. Like in nature, initially the monkeys were there, then they evaluated into human beings, and like that. So means the human beings are the most complex, so complex things are generated from the basic things. So basically a complex software is generated from a simpler software. So this is the concept of versions. So you implement some basic functionalities and release the version. So that is the version, call it version 1. Then you improve upon its functionalities and release version 2. That is the concept here. Some is there. Another design model is iterative. In this you add the functionalities one by one. So like for a simple example, we can consider a word processing program like this Microsoft Word itself. So here we can add the functionalities one by one. So here first of all we add only one font, then we add some new fonts. So fonts functionalities, then we add this, we should be able to change the size also. So then this functionality is added, then this functionality, and then finally this complex program is arrived at. Okay, so this is one concept, this is one design process. So basically whatever design we follow, you divide your software development in phases. First is like requirement analysis, what the user wants from your software, then design overview, and then finally is coding, testing, and management. Okay, so these are the basic phases. So you should follow this design phase. Okay, the third point I will discuss first: UML. See, diagrams give a concise idea about the software design and take you a step further towards the code. That is, you are more nearer to the code now, because diagram explain the problem better, and these can also be used by reference by the client. So now I discuss second point. Second is the solid principles. These are very important principles in object oriented. One point, I am discussing object oriented software design. So these are very important principles in object oriented software design. So basically S stands for single responsibility principle, O stands for open close principle, L stands for Liskov substitution principle, I stands for interface segregation principle, and D stands for the, what is that? Dependency inversion principle. So basically these are the most important principles as far as I know. So I will explain in further lectures, but in this I can give a brief overview of what these means. So basically single responsibility principle is this: you give a class a single responsibility. A class should not have so many responsibilities, otherwise many classes will depend on it and the design becomes very much coupled. That was a problem with initial versions of Mozilla software. So then open close principle. So design should be open for extension but closed for modification. So anybody could not change your code. Basically it should be closed for modification. But if in future we want to add more functionalities to the code, then we should be able to extend it. Then Liskov substitution principle. So basically here actually, how can I explain? It basically means that the parents should not be aware of the children classes. This is the basic concept. So this is the concept. Liskov substitution principle I can't explain here in that much detail. In further lectures I could explain. Interface segregation principle is this, that okay, suppose an interface is fat means it is having so many methods. So, and so if suppose class A implements that interface, class B implements that interface for some methods, class A is implementing that interface for some methods, class B is implementing that interface for some other methods. So it is having both their methods, like it is having the methods for class A also, class B also. So it is basically becoming fat. So we should segregate the interface into two interfaces, one for class A, one for class B. This is a basic thing. And dependency inversion principle is basically, it states that the higher level modules should not depend on the lower level modules. Both should depend on abstractions. This is the main concept here. So we should basically, higher level modules is, if it is directly dependent on lower level modules, then we can't modify it. So basically, if both are dependent on some abstractions, then we can easily modify our code. This also I can't explain that much detail here, but in a later lecture I will, like the Liskov substitution principle. So 1, 2, 3 I have discussed. The fourth and the very important point, Isaac Newton wrote, if I have seen further, it is by standing on the shoulders of giants. This was written by him in a letter to Robert Hooke. This letter is very famous. But in software, we tend to ignore this fact and do two mistakes. So this fact told by Isaac Newton, we tend to ignore this fact. This is a very basic fact. It is applicable in many fields of life. You should take benefit from what others have done in past. Otherwise, you could not do so much. So we do two mistakes. Number one, we start from scratch. It wastes time and effort also. It is hard. And finally the design is also not good. So everything is bad here. And the other thing is, we do not learn from the mistakes of others. Okay. And suppose Windows has done that mistake in history, Mozilla has done some mistake in history. So these are very big softwares. So these mistakes would have surely been solved and will be formulated into a set of principles or guidelines that, if followed, could lead to better software design. So we should definitely look into that here. Okay. So how to develop over others, basically. So the first point is, we can use libraries which most of us do, like the Java library collections and all that. Second thing is frameworks, which basically like the Bootstrap web development framework, jQuery and all that. So basically buttons etc. are provided there, and we write our whatever text we want in the buttons, and all this means the basic functionality is implemented and you can change it whatever way you like. So basic framework is provided. There is a skeleton. And the third, and these also many people use frameworks, these are very popular. Bootstrap is the most popular project on GitHub, and this Java libraries we all are using, most 99%. If you are not using, then please use them. Okay. And patterns is the third thing, which is a very good concept. Patterns are basically more abstract than frameworks, but this is very less popular, I guess. If you go to some software company, then they should introduce to you this concept to you, but if they don't do this, not good. But very few of us use, means in colleges, I think in schools or colleges very less people are using this concept. Some students are not familiar with this concept, so they are not using and they don't care. So we think we should just code. Why care about so-called principles here? What is in the principles? But believe me, they do not only make our design better, but help make our code manageable and understandable in future. So these patterns are basically some problems. A problem statement is there, some like if you want to do this type of design, then what steps would you take, what would be the skeleton of your code, the basic structure of your code. Then the solution is provided, that this will be my basic structure of my code, and the context in which this solution is applicable, the context of the problem, this context thing is also there. So basically these are the concepts. So I will discuss in my further lecture also about them in detail, but these are very important concepts and we should not ignore them. They could help make our code very good. And when we are doing teamwork, that is 7-8 persons are working on the same software, or many hundreds of the persons are working on the same software, then you should have coordination among yourselves. So if you follow a set of principles, then the coordination is better. So in a company, this is very important thing. And if you are writing the code individually, then also this is a very good thing. So okay, thanks.